Hello everyone. In this tutorial video, we are going to cover different types of sensors. So let's get started with the first one, that is IR sensor. As you can see in the image, this is how an IR sensor looks. It has two different types of LEDs. First one is the IR emitter LED and second one is IR receiver or photodiode. Based on this, the IR sensor is classified into two different types. That is, first one active IR sensor, in which both these LEDs are present on the sensor, and the second one is passive IR sensor, in which only the photodiode or IR receiver is present on the sensor. With this image, we'll understand how an IR sensor works basically. The IR LED emits IR lights, which when reflected by an object is detected by the photodiode or the IR detector, and then the signal is sent by the IR sensor. This is how simple an IR sensor works. Now, for its better understanding on how it is interfaced with Arduino, we'll go to tinkercad.com and see. So here we are on the tinkercad.com. Go log into your account which you created earlier. As you can see, I have already logged into my account. Moving further, we'll go to the circuits and create a new circuit. We'll give this circuit the name as IR sensor. Next up, we need components. For that, we'll search Arduino. Here comes up our board. Next we need is IR sensor. You can see the IR sensor. We'll pick it up. Now here you might observe a little bit change from what we have seen earlier in the image of IR sensor. So this is the second type of IR sensor called as passive infrared sensor, which only consists of the photodiode. We'll see how it works. Next up we need an LED for the output of this to indicate the output of this IR sensor. We'll start making the connections. Anode of the LED is positive and cathode is negative. So we'll connect the cathode to ground and we'll connect the anode to pin number 12 on the Arduino. We'll give it red color and ground is black color. For the connections of the sensor, there are again 3 pins: power, ground and output. We'll connect the output to pin number 4 of the Arduino pins. For ground, we'll connect it to GND on the other side. And for power, we'll connect it to the plus 5 volt or VCC. Change the colors of the wires so that there is no confusion and for better understanding. Now it's time to code so that the circuit works. So we'll go to the code part. Here we'll select text and we'll just ignore this warning. We'll clear our screen. Okay, so we'll start writing the code. First we'll define the ports for IR in LED. That is, int IR is equals to 4 and int LED is equals to 12. Next up is the void setup part. That is, we need to set the pin modes for the IR and LED as input and output respectively. So pin mode for IR as input and pin mode for LED as output. This completes the setup part. Now we need to write the void loop part. So here we'll use the if else condition. That is, if digital read of IR equal to low, then we need to give the LED as high. For that we'll use digital write. So digital write LED and high. We'll close the if condition. If this isn't so, then we'll write the else part, that is simple digital write for LED as low. That's it. We'll close the else loop and we'll close the void loop. That's it, our code is complete. But now we need another component, that is remote, IR remote, for giving instructions or for passing the IR rays from this remote to this photodiode. We'll start up with the simulation, and as you can see, when I press any of the buttons of the remote, the LED is glowing. So that is simple IR sensor working. So now the second type of sensor that we are going to see is the ultrasonic sensor. The image shows the ultrasonic sensor and its basic working. The ultrasonic sensor has two parts, transmitter and receiver. The transmitter transmits sound wave at frequency above the range of human hearing, and the reflected waves by any object is received by the receiver part. This sensor is used in many security systems, automatic door systems, and to measure distance as well. This working is simple. The transmitter transmits the waves and the reflected waves are received by the receiver, which in turn send the signal. The sensor has 4 pins. First one is power, second one is trigger, third one is echo, and the fourth one is ground. Now we'll see in Tinkercad how it is coded and or interfaced with the Arduino. So we are again back to the tinkercad.com. So now we'll be going to create a circuit for the ultrasonic sensor. So we'll go to the circuit section and create a new circuit. We'll name our circuit as ultrasonic sensor. Next we need to start selecting components. Firstly we need Arduino. We'll search for it and take it from the component section. Next thing we need is the sensor, that is ultrasonic sensor. Now as you can see, it is showing us two types of option, two different ultrasonic sensors. So we'll see what is the difference between them. Now as you can see, one sensor is having 4 pins, VCC, trigger, echo and GND, and the other one is having GND, 5 volt or VCC and signal. So no need to worry. The difference between them is the trigger and echo pin of the 4 pin ultrasonic sensor has been combined to one single pin called as signal in this 3 pin ultrasonic sensor. So this is signal, power and ground. In this tutorial we are going to use the 4 pin ultrasonic sensor for better understanding. Next we need is a buzzer. This time we are going to use a buzzer instead of an LED to indicate our output. Buzzer is having 2 terminals, positive and negative, so we are going to do the connections accordingly. We'll connect the negative to the GND of the Arduino and shift it a bit downwards, and positive to terminal 11. We'll change the color wires so that we don't have any confusion. Next is we need to connect the ultrasonic sensor. It is having 4 pins. VCC is the 5 volt again, so we'll connect it to 5 volt. Trigger will connect to pin number 3, so we'll take it this bit above. Trigger will connect to pin number 3 of Arduino. and echo will connect to pin number 2 of the Arduino. Now the ground is remaining, so we'll connect the ground on the other side of the Arduino board. We'll change the colors of the wire again so that there is no confusion, and for better understanding, VCC red. We'll select trigger as any color you want of your choice, make it yellow, and for echo we'll use blue, turquoise. Now the next part is that we need to write the code for this circuit. So we'll again go to code window, we'll select text, again continue, ignore that, and we'll clear the screen. Okay, so now we'll write the code. We need to define the trigger, echo and buzzer pins, that is int trig equals to 3, int echo equals to 2, and int buzzer equals to 11. That is, they are connected on the respective points of the Arduino. Next we are going to need two variables, so we'll define them. One is time taken and other one is distance. Now comes the setup part for the trigger, echo and buzzer pins as output, input and output respectively. So we'll write void setup pin mode for trigger as output, pin mode for echo as input, and pin mode for buzzer as output. We'll close the void setup. Now comes the part of void loop. Now we need to initialize the sensor first. So sensor, that is, we need to first set it to low for some delay of microseconds. Then again for some delay of microseconds we need to set it to high, and then again to low. So we'll write digital write trigger pin, and we'll first need to set it as low, then we'll give delay of microseconds of about 2 microseconds. Then we need to again set the trigger pin to high, and now we'll again set it to low. Digital write trigger pin to low for about delay of 10 microseconds. Now we'll use the time taken variable by using the pulse in command to store the particular time when the echo pin is set to high in the variable time taken, and we'll calculate the distance as time taken by 29.1, and we're going to need half of that distance, so 29.1 into 2. Now you might be wondering where this 29.1 value has came. We need to take this value from the data sheet, or you can take the value from the data sheet of the ultrasonic sensor for the particular distance calculation. Now we are going to use again the if else statement, that is, if the distance is less than, let's say, 250 centimeters, then you need to set the buzzer to high. So digital write buzzer as high, we'll close the if, or else we need the buzzer to be off. So digital write as buzzer comma low. We need to close the else part, and we need to close the void loop. So our code is over. Let's start the simulation and check it's working. As you can see, it is in the range that is less than 250, so the buzzer is ringing. And whenever this pointer goes out of the range of the sensor, that this red color part is the range of the sensor, the buzzer stops. We can again check. It is not in the range that we defined for the if statement, that was less than 250, and now it is 263, so the buzzer is not ringing. As soon as we get the distance to less than 250, the buzzer starts ringing. So that's all. This was the working of ultrasonic sensor.